All right, hello there. This is problem 35 on page 381. That was section 5.4. And this is that problem that people had some questions about how to make it work and how they knew they were supposed to solve the problem in this way in class. The problem asks you to evaluate this trig expression, and it gives you this equation right here. And what I want to draw your attention to is notice there's no x's or anything like that in this equation. This problem is just numbers. I mean, they're awkward numbers. You don't know off the top of your head what pi over 12 is or pi over 4, but they are a number, and that's the size of an angle in radians, and therefore the sine of that angle is a number, the cosine of it is a number. This is just a number. There's actually a couple of ways you could solve a problem like this, but the problem is in a section 5.4 that's about the angle sum formulas and the angle difference formulas. Well, that should be a hint as to how to solve it, but like I said, we're going to see that there's more than one way to do it. Now, this pi over 12 is what spooks me in this problem. We have been working with the unit circle in the front of your book for quite a while, and we've never seen a pi over 12 before. But we could use the angle differences to realize pi over 12 is the same thing as pi over 4 minus pi over 3. That is actually a mistake. Let me fix that right here while we're here. That's actually pi over 3 minus pi over 4. I know I have it fixed in other parts of the handout here. So it's pi over 3 minus pi over 4. Okay, so any place we have pi over 12, like right here or right here, we could replace it with pi over 3 minus pi over 4. They're the same thing. Same with right here, pi over 3 over minus pi over 4. That's the same thing. But that is a angle difference formula, which again is in the front of your book, or it's at the beginning of this section 5.4. However you want to get it, that's fine with me. So, all right, what is that one? It's sine of this one times cosine of this one minus cosine of this one minus sine of this. All right, so here it is. Sine of pi over 3, cosine of pi over 4, minus cosine of pi over 3 times the sine of pi over 4. All this stuff in these square brackets right here is just the angle difference formula associated with this one right here that I'm highlighting. Okay, so all of this little bit gray box right here right now becomes what's in these square brackets right here. And I'm just going to copy this cosine pi over 4 down to right here. Plus. All right, here's the other the angle difference. This is cosine of cosine of u minus v. Well, we have an expression at the beginning of this chapter or in the front of your book. It's cosine of u times cosine of v plus sine of u plus times sine of v. But that's what this is right here. This stuff in these square brackets right here is the angle difference formula for this one right here. Cosine of u, cosine of v, plus sine of u times sine of v. So everything that's in the square brackets comes from this right here, and then that's sine of pi over 4. All right. The nice thing about this, I know it's hard to imagine there is a nice thing because there's such a big mess here, but this pi over 3, pi over 4 stuff, those are values that are on the unit circle. I mean, you can turn to the unit circle at the front of your book, and there are values of sine and cosine for those particular angles. We can look them up, and we can see that the sine of pi over 3 is square root of 3 over 2. The cosine of pi over 4 turns out to be square root of 2 over 2. And we can just keep picking those off and just pull those off of the unit circle, place after place. And I know it's a mess, okay? But it can all be picked up off of there. All right, from there down, it's just algebra. Well, no, it's not even really algebra, it's arithmetic. But it is messy. I mean, it takes a while to find to put these two together, multiply this one by this one, put them together, factor that 8 out in front. You eventually get this 2 plus 2 and this negative 2 cancel each other out. You end up with 4 square root of 3 over 2 or square root of 3 over 2. I'm sorry, 4 square root of 3 over 8 or square root of 3 over 2, which is the answer in the back of the book. So I think this is the way they want you to solve it, using this angle difference formula. But a perfectly good question came up in class, and that is, how are we supposed to know that? How are we supposed to know that this was supposed to be solved as an angle difference formula? Namely, to expand that pi over 12 into pi over 4 minus pi over 3. Again, I have that one backward. Let's fix that while I'm here. It's pi over 3 minus pi over 4. All right. And then you're supposed to use that angle difference formula. Well, truth be told, you wouldn't have had to do it that way. There, in fact, are other ways that you could have solved this problem, and I'll show you two right below, like using a calculator. But really, in this particular problem, this thing about pi over 12 is a pretty good clue about how we're supposed to solve this problem, because pi over 12 is not on the unit circle at the front of the book. If you got yourself a different copy of the unit circle from a different book or a website or something like that, it might have been on there, but in general, that's not one that's going to be on there. So to get that pi over 12 out of there is going to have to be, we're going to have to replace that pi over 12 term with something we do have, like pi over 4 and pi over 3. So those are like hints as to how to do it, but there's no doubt about it. You perfectly could have just done this using a calculator. And in fact, as we talked about in class, plenty of people did. So, well, I don't have a problem with anybody do that as long as you do it right. And so if you're careful about it and plug the numbers into your calculator, let me fix the typing error there, and do it, you're going to get an answer. Now, I actually did it on Wolfram Alpha, just because, I mean, if I sat here and pounded it on a calculator, A, I don't own a calculator, so how would I have done that? But B, it's hard to show a calculator screen inside of a Word document like this. So I did this at wolframalpha.com, and here's a screenshot of that. I typed in the sine of pi over 12 times the cosine of pi over 4 plus the cosine of pi over 12 times the sine of pi over 4. You can see it figured out that that is the equation I meant. It looked at my search term here and it figured it out, and it did the analysis, and it comes up with a number, 8.66 something. And as you can see, the answer is 8.66025 blah blah blah. Now, in the case of Wolfram Alpha, the software that runs this is actually based on Mathematica, which is a very powerful software system. It knows how to figure out that that's actually square root of 3 over 2, which is our answer. But in general, your calculator is not going to be able to do that. Calculators don't, in general, give you the answer in forms of things like that. You're just going to get those digits, 0.866. Okay, that's fine. But here's the deal. How will you know you did it right? Because the back of the book is going to give you the answer in the form square root of 3 over 2. Well, that's fine. Just go ahead and evaluate square root of 3 over 2 in your calculator and make sure that it is also 0.866032, just like you have right here. And as long as you get the answer from the back, the answer you got in the problem and the answer you get from the back of the book match, that's just fine. I really don't care that you didn't use the angle difference formula in this particular case, because demonstrating skills using your calculator to solve trig problems is a valuable life skill too. I'm not worried about that. All right, well, I'm glad that we got this one sorted out. It was a little bit of a mess in class. And, this handout that I just made right here, I'll give it to you if you want it. And please let me know if you have any questions.